Welcome, everyone. I do know I'm the session before lunch, so I hope that every extra minute I take will keep you from lunch. I'll be try to be considerate of your time too. My session will be about GraphQL. So just to get a basic idea, is anyone here using GraphQL? Okay, that's good. That's good, like almost half of you. So part of it will be also sort of a recap of what GraphQL is, but then I just know I can go past these kind of things quickly. It's also nice to be back at this conference. Has anyone been here before? I've been. Some of you have. That's great. That's great. So last year I was doing a workshop. I think we took a picture at the end of the conference, but you can just see my glasses and my hand. But it's always nice to be back here, especially the organizers are really friendly and really trying to create a nice community around the conference as well. And of course, being in Porto, you also have these francesinhas, which I really like. I don't think my doctor or my trainer likes me eating those, but I'll again be looking forward to have one of these later tonight. Yeah, they might as well. They might as well. But when in Porto, it's okay. So a little bit about myself. My name is Roy. I used to work at a startup called StepSen, but we were acquired by this little company called IBM. So I'm working there now. I still have these old Ninja stickers, so if you have kids, they will probably love the Ninjas. I brought some of these old stickers, which are sort of collector's editions now. I also write some books, mostly around web technologies, such as TypeScript or React, but also a book around full-stack GraphQL development. And I also like to go to conferences like these ones. So if you would search for my name on YouTube, you will be able to find some previous presentations. Also around microservices. So if you watch the previous talk and you want to know how GraphQL sort of fits into microservices, make sure to search for my name and microservices, and you should be able to find it. So I think the very first topic we should address before seeing how we can performance test the GraphQL API and see how performance might compare to other API specifications, specifically REST. It's good to have a look at REST APIs and how they are different from GraphQL and sort of what kind of problems GraphQL might solve for you if you are using REST today. Because I still think most of the debate around GraphQL is it better than REST? Should I use it instead of REST? If you're working more as a front-end developer, is someone here a front-end developer? Oh, nice, quite a few of you are. If you are a front-end developer, you might also wonder, should I use something else like tRPC or maybe a different RPC format instead of GraphQL? So those are all valid questions. I'll have some answers to those questions at the end. But first, I wanted to mainly look at REST APIs and see what kind of problems GraphQL will usually solve for you. So let's suppose you're working on an application, and this can be a mobile app, it can be a web app, it can be a PWA. I think those are quite popular as well, especially if you're building for Android phones. So suppose you're building a UI and you need a REST API in order to get all the data you need and display it to your users. I've been in e-commerce for a long time, so I've built a lot of those sort of product pages, which you can see right here. So it's just your typical product page. It displays a thumbnail, a title, some reviews. It has a breadcrumb that sort of shows the category the product is placed in, and you can also find the price. But most often, in order to fill this UI with all your data, you need to send a request to multiple endpoints. Probably the first endpoint you need to reach out to is an endpoint that gives you information on the title and the price, and maybe it also has the thumbnail for your product. So this usually comes from like a product's details endpoint. It's probably something called API/product/some identifier, and you would be able to get these sort of strings of information. But probably if you want to display this breadcrumb, you need to send a request to an additional endpoint. Maybe you have something called product slash the identifier slash categories in order to retrieve the categories you've attached to this product. Could be the same maybe if you have tags attached to your product, or maybe even if you have multiple thumbnails, you have a specific endpoint that returns a list of potential thumbnails. Maybe some of those are optimized for mobile, maybe some of those are optimized for specific countries, because maybe there's some language inside of your thumbnails. And then probably if you want to display ratings, you need to send a third request to something like Trustpilot maybe. I guess they're pretty good at helping you with collecting reviews for your products. Maybe you have your own products review system and you need to send a request to get information from that system. But coming down to the fact that in order to fill this UI coming from the REST world, you would need to send multiple requests in order to get all the data you sort of need. So this is something we call underfetching if you look at it from a GraphQL perspective. It's also something we call the N+1 problem, where you don't need to send one request, but you also need to send a second or a third or a fourth or no matter how many additional requests in order to collect all the data you need. So this is something we call underfetching, because the single request doesn't give all the information you need, so you're basically underfetching your API, and you need to send a second or third request to collect everything. I've seen people trying and solve this from a REST API. And you can do this. If you're working with REST, it's always good to think about if you're building a REST API, if it would be a RESTful API, where you're sort of following the REST specification, which is pretty old. But there is a REST specification, and this specification will tell you, it will basically tell you to structure your endpoints by entity type. So if you have a table in your database called products, it should have its own endpoint. If you'd like to get a single row from this table, it should have an additional endpoint. If you have a different table with a relation to product, it probably shouldn't be exposed over the same endpoint, but it should get its own endpoint as well. So this is more of the RESTful specification. I guess what became kind of popular is REST-ish, where you sort of hack query parameters inside your URL. You would take these parameters, and then based on this, you would change the data structure. It's okay if you use query parameters to change the rows that are returned. So if you want to filter or something, that's perfectly fine. If you're trying to delete something from the data structure, so maybe you're trying and take out some fields from your result, I don't think you should do that, and I don't think, well, I'm pretty sure it goes against the official or the first REST specification, which said you should return a fixed data structure rather than sort of mess with the data structure as you add more parameters to a URL. So in REST-ish, it's perfectly fine to filter your data. You shouldn't mutate the data structure or try and change the data structure by adding these sort of field parameters to try and limit the fields that are returned. So underfetching is one valid reason to use GraphQL. But of course, if you are using a REST API and you have this sort of underfetching approach where you need to send multiple requests to get all your data, you should also think about the fact that every request is requesting data. So for every request, data will be sent to your mobile application or to your web application. It will be received by the user, and the user needs to process this in their browser or mobile phone. So each of these requests will load data, and it might look like this. Every request will collect a whole bunch of data. Usually it's JSON. And maybe from all this JSON that you receive, it could be a few fields. It could also be hundreds of fields. I've seen pretty bad, I wouldn't say bad, I've seen REST APIs that return hundreds of fields. And you don't want to use these sort of endpoints in your application directly because, well, there's more data than you actually want to show. I think it also led to a backend for frontend pattern where people would create specific endpoints for specific use cases. That's something I see happening in REST as well, specifically to limit the amount of data that's being sent to the applications. But imagine you're getting all this data in your application, but you only need a several number of fields. So in here you can see that we're trying to render the title and the thumbnail. So we take these fields, we take our JSON response, and we sort of filter out or destructure it to only have the data we need. Then you can do the same for all these other endpoints like categories and like ratings, because each of these endpoints will return more data than you actually need. And this is something we call overfetching if you look at it from a GraphQL perspective. You're sort of overfetching your API because you're taking more data than you actually need, which usually is fine. I mean, when GraphQL was created, it was created for mobile applications specifically, where Facebook saw that they were loading too much information on all the different endpoints, or they were sending too many requests to different endpoints. Specifically, as this was back in 2012, we had different phones, and we had different cell phone plans, and it was pretty hard to load megabytes of data because it was either too fast or you would run out of your data plan. Today, it doesn't really matter anymore because we basically have an unlimited data plan. There's Wi-Fi everywhere, and the connection is pretty good. I mean, 5G is often faster than Wi-Fi I get in hotels when I travel to conferences, so the internet's pretty good today. But these problems are still there. We don't really notice them anymore because, well, sort of all the additional things like the internet, they have been updated. So it doesn't matter that our APIs might still be slow, or we still have overfetching or underfetching in REST, because the internet solved our problems. But these problems are still here, and even if you think about things like the climate, you might even assume that, well, it could be a good thing if we're sending less data back and forth. So overfetching is another valid reason to start looking into GraphQL. So if we look at GraphQL, and as some of you have worked with it before, you can see in the GraphQL world, you would have a single request. And in this request, you can collect all the fields you need, and only the fields you need, because you have control over the fields that you receive, so you would only add the fields that you need to your request, and those are the only fields you get. And you can also see you only have a single request, because it's something that sets GraphQL aside from, for example, REST. All the data is being processed or transported over a single API endpoint. So you don't have this sort of categorization by endpoint. You only have one endpoint, and depending on the request you send to this endpoint, you will get information back. So how does this work? And we're going to be quickly on this part because a lot of you have worked with GraphQL before. At the base of a GraphQL API would be a GraphQL schema. And you can look at the schema as the specification of your API. And more specifically, it describes all the data that's available, and it also describes the ways you can get data from this API. If we look on the left part, you can see the data structure is described. So this would be a total description of all the data. You can look at the GraphQL schema in the same way as you look at a schema for a database. If you've been working with SQL, I like to say GraphQL is a query language much like SQL, not for relational databases, but for APIs. Because you would define the data structure, and then later on you would be able to use a query language to extract this data from the database. So in the GraphQL schema, the entire data structure is defined, and you can also find the operations in here. There's 3 types of operations in GraphQL. You've probably heard about queries. So queries is a way to read data from a GraphQL API. You then have mutations, which is a way to mutate data. And I actually saw a funny tweet about this where someone proposed REST API should only transfer data, or should actually be able to mutate data over POST methods. And this is kind of funny because in GraphQL, all your data, all your mutations, they're mutated using a something called a POST. So in REST, you would have post, put, patch, and delete, basically to mutate data. In GraphQL, all your requests are posts. So if you look at it from a REST perspective, it might be weird at first, but most of the sort of actual action that you take, either inserting data or editing data or delete data, you can put those details sort of in the operation name. You can see an operation here to just collect a single product. And you can also see it takes some parameters, and it also has a return type. So all of this is in the schema, meaning that as a developer, when you look at a GraphQL API, quite often you're able to look at the schema as well. We call this introspection. And then based on the schema, you would be able to figure out what sort of actions you can take, what data is available, and of course all the tools in the ecosystem, they're working with this schema as well. Then in order to get data from this GraphQL API, you would send a request. And in this request, you would pass along the operation in the body of the request. So that's why everything is a post, because for a GET request, we're not able to send along a body. So in this body, you can see that I'm requesting a query. So I'm reading data. My operation field is product, so I'm trying to get a product. I pass a variable for the ID, and then I select a whole range of fields. So these are the fields that I get in my response as well. And you can also see that, clicking too fast. Oh, whenever we get the data back, you can see it's always wrapped in a data field. And this is because the data field will consist of your data. So in here you can see the top level field product is returned. You can see all the fields that we requested. You can see some relational or nested structures there where we have reviews and offers. So why is everything wrapped in a data field? It's because you can also get incremental data or partial data, depending on what's going on. Meaning that if one of these fields isn't available, you might be receiving null. And you could also get a field called errors, which sort of describes why you get an error or why you're not getting the data you want. But something GraphQL does, it will give you the data that it can actually retrieve, and then tries to put the errors in a different field object. And this, of course, is following the same format as a request, making it pretty easy for us to sort of understand what's going on. So you probably think GraphQL should be good for performance then, right? Who thinks GraphQL can be good for performance? Some of you think. Not everyone is convinced yet. So I'll try and do the convincing later when I show you the demo. So let's try it out. I built a small demo for you. I also deployed a GraphQL API. And in this GraphQL API, I'm going to sort of mimic the behavior of a REST API for a very simple reason that it would be pretty hard to compare a REST API one-to-one to a GraphQL API because they might be built using different frameworks, they might be deployed in different cloud regions, and so forth. So what I've done, I've basically created a GraphQL API, and in this GraphQL API, I have queries to read data from data entities one by one, and then I have queries that combine data entities into one single request. And this way we can sort of mimic what a GraphQL API looks like. It might not be a one-to-one sort of comparison, but it's the best I can do given all the constraints of working with different frameworks, different servers, and caching and everything you can think about that comes by looking to build an API. So I also like to say the proof is in the pudding. I believe this is quite a typical pudding to eat in Portugal. I remember I had something like this before here. So the proof is in the pudding, and that's why we're going to do some performance testing in order to see how GraphQL sort of compares to REST, and if we can see actual performance benefits and what those performance benefits would be. And for this, we'll be using case 6. So case 6 it's maintained by Grafana, and which you might know if you're working with backend systems and you're collecting data. It's an open source framework, or maybe not really a framework, more like a toolkit to performance test APIs. And what I'll be showing you also works for REST APIs. So if you have a REST API and you're not looking to use GraphQL, but you still want to apply performance tests, then you should be able to do this using the information in this blog post as well. So case 6, you don't need an account for it. Of course, they have cool things if you sign up, but it's also open source. You can just run it basically on every computer. If you go to this blog post, you should be able to find the links to install it as well. It's going to wait a few seconds for people still scanning it. Okay, so we have 3 more seconds to scan it. Okay, great. Maybe just take a picture of it first and scan it with your neighbor. Might also help. So I hope the resolution of these screens is is good enough to actually scan it. I think it is. Otherwise, just search for case 6 in GraphQL. This should be one of the first hits on Google. Maybe also on other search engines, but I try and stick with Google. So this is the example. I need to close the presenter mode. And then let me go to a VS Code project. Is this large enough? I think it is, right? Might even be a bit smaller. Still large enough? Yes? Okay, good. You've better eyes than me then. So I set up a few JavaScript files. So case 6 is using JavaScript as the runtime to work with this. It also heavily depends on Wi-Fi. I think I have Wi-Fi, so that's good. Otherwise, I can also go to my hotspot later on. So with case 6, you can performance test HTTP requests. And GraphQL is, well, it's transport layer agnostic, but most often it's just transported over HTTP. And as REST APIs are transported over HTTP as well, we should be able to sort of find out what the differences are. So I've created a GraphQL API based on a REST API. So this is something I see happening a lot. Companies already have developed a lot of REST APIs, and then they figure out they're building backend for front ends in order to sort of tailor the data to all the different applications they're building, sometimes even ending up with multiple backends for front ends that need to be maintained by different teams, or they are maintained by the front end team that doesn't really have any backend knowledge. So it gets kind of messy, and that's why people like GraphQL as well. So I've created a GraphQL API based on a REST endpoint. If you would go to this REST endpoint, you can basically retrieve a list of customers. And in this list of customers, you can find the address of the customer, which will be a JSON object, and it will have several fields. You can also retrieve the email, the ID, and the name. So this query, so this get customer list query, it does the same as sending a request to this endpoint. So if I want to do a performance test of REST, and I want to do it in a similar fashion or a similar environment as I'm going to do my GraphQL performance test later on, it's best for me to use this query because it's running through the same system. If I would be testing this API endpoint directly, I would get different results because I've created a GraphQL API based on this REST endpoint. This thing is also deployed somewhere else than this API, so it would lead to a messy situation. So for now, I'm going to use a query that has all the fields that are available in the REST API, and then we can just focus on what's happening there. It is taking this GraphQL endpoint. As you can see, I'm doing a post request. I'm passing along my query, so this guy here, and then I need to set some headers. So the content type header is actually important in GraphQL because all the data you receive is JSON, so you need to set this header as well. So this is my query, and at the top I actually pasted this, so it's easier for me to remember. So for my terminal, after installing case 6, I would be able to run basically this script. And it's very basic. I'm just doing a HTTP post request with my query, with my endpoint, with the headers. I'm going to use 10 virtual users, meaning that over the duration of 30 seconds, 10 virtual users will try and send as many requests to this endpoint as possible, and also pass along my GraphQL query. And of course, this is the file I'm working with. So it's also good to know that these virtual users will wait for the query to finish. There's no batch operations or anything set up just now. So if I run this request, we have 30 seconds for the test to complete. You can see actually results as soon as it starts running. You can see we have like 20 seconds left. The 10 virtual users are working on it, and they're trying to send and complete as many requests as they can. It's good to know that you can also use case 6 in sort of a Docker environment, so you could even deploy it to your servers and run it there to get some actual insights. So this one is almost finished. We can get some results here. Make this a bit bigger. So what case 6 did, it sent 2,000 requests and completed 2,000 requests in these 30 seconds to my GraphQL API. I used a query that has all the fields that my REST API endpoint as well. So I'm going to say this is like the closest as I would get to compare GraphQL to REST. So let's consider this is a REST call. I'm receiving 6 megabytes of data. And this is largely because I'm getting all the fields from the REST API and in this solution GraphQL API back, even though I'm not using these fields. So I'm getting an address. Well, maybe I don't want to display an address. I'm getting someone's email. Well, maybe I only want to display their name. So that's why you can see a lot of data being received. So 6 megabytes is a lot. If you look at this, 10 virtual users over 30 seconds trying to send requests. If you're working with if you have a product that's quite popular, 10 virtual users or 10 users isn't that much. 10 users clicking as much as they can in 30 seconds is probably something that wouldn't happen very often. So you also need to find a way to interpret these results in a way that makes sense for your product. If you're building a dashboard and someone is clicking maybe a couple of times every minute, then you need to tailor your test in order to sort of mimic this environment as well. It doesn't really make sense to look at the duration of the requests, because this all heavily depends on my server. If I build my server inefficiently, then of course it will take longer to complete a request. If I've made any other mistakes, if I'm sending a request from here in Europe and my servers are in the US, it will also slow down my response time. So the biggest thing I want to look at is the number of requests I was able to do and complete, and then the amount of data I received. So we mimic the REST API in this example. So let me actually write down sort of the results I have. And this is always a bit annoying because I need to bring this back. So for sort of a REST API, we did 2,000 requests. And we received 6 megabytes of data. So quite a lot. But as we are building our GraphQL API, we don't want to receive all these fields. We just need the fields that we want to display in our application or that a designer came up with that we want to display. So maybe I don't want to have the address, but let's keep the address in just for fun. But I don't need all these results. I just want to display someone's city. Because maybe you're building some overview of your customers. You want to know the name of the customer, their email and their city, or maybe we can also get rid of email. We just want to render a list of names of our customers, and then we want to display the city this customer lives in. So if you look at this, we're deleting all these fields, meaning that probably we should receive less data from the GraphQL API, and we also are able to do more requests. So let me save this example. So now we're going actually into a place where GraphQL makes sense, because we don't want all these fields, we just want a subset. So I'm going to run my test again. I'm going to keep these results up so we can compare them later on. It will take another 30 seconds. So if someone has a really great joke, then you have like 25 seconds left. If not, that's also fine. Now I'm really bad at jokes myself. Somehow I always keep getting jokes that people already know, so well, not going to try it anymore. I do have a fun story around the first time I used K6, by the way. So I'll be sharing that story later on in our next 30 seconds. As this one is almost completed, so in here we sent a different request, and we requested less data. So you can immediately see that instead of receiving 6 megabytes of data, we only received half. So this is really cool. We received half of the data, and if we look at the number of requests we were able to do, I guess this is pretty similar. So yeah, there's only a small difference in the amount of requests we were able to do. So this could have multiple reasons. Maybe if I run it again, it's slightly more. If I take a longer time span, you can also see bigger results from this. But the main point I wanted to show here was the data received. So we already cut down the data that's being sent to our application by half. So this already shows the huge potential or sort of win you can get in the amount of data being sent to your application just by limiting the amount of fields someone receives. So this is just a basic example because, well, we took one GraphQL query. We saw, well, let's round this off to 2100, but we received only half of the data. It's like 2.6 megabytes. Even if we round it off to 3, we can still see a huge difference. So this is the first win you sort of have if you'll be using GraphQL rather than REST for this specific example. Of course, you could create a new endpoint for this, and this is something I see happening a lot, as I explained, where people would create specific endpoints for specific needs in their application. And this is perfectly fine, but you also need to think about the maintainability of this, because if you create new endpoints, someone needs to maintain those endpoints. If you make a change somewhere in your backend, this endpoint might change, and people might get mad. You need to document these changes. So this is one reason I really like GraphQL. But this is just a single setup. Let me go to a slightly more complex example, and we call this multi. So one thing you can do in GraphQL, you can make combinations of data. Whereas for REST APIs, you would need to send different requests to combine data. So we have an endpoint to get all our customers. It's the same endpoint we used before, so this would retrieve a list of all our customers, including their address, all this information that we may or may not need, and then some things like email and name. But maybe I also want to get the orders for every customer, because maybe I want to get this list somewhere and display it in my application. So in order to get the list of orders for a customer, there's multiple ways to do it in REST usually. You would either send a request to something called /orders and then apply some search. So maybe you have something like this, like customer ID equals this. This could be a way to do it. What I also see happening a lot, and which I personally like most, is if you would have a setup like this, where you would send a request to your customer's endpoint, you would get a specific customer, and then for the specific customer, you would like to receive the orders. So there are multiple ways to achieve the same result, usually in REST. So we would have either this one or the one I had before, which is this one. So in GraphQL, I could just use a query for this. Again, as I'm trying to mimic the REST API example, I'm going to be taking all the fields I have available for the orders. And I take all the fields I have available for customers. So if I'm in a REST world, I need to send 2 requests. I need to first get my customers, and then for every customer, I need to get their list of orders. So it's 2 requests I need to send rather than 1. I'm going to cheat a little here, because I'm going to be assuming you use a batch request in order to collect this data. Maybe you aren't using a batch request. That's perfectly fine, but it's going to slow things down. So I'm hoping you do some optimizations like using batch if you're sending multiple requests at the same point and you need to collect this info as well. I know it's a bit hard to do batch requests from like client-side JavaScript, but there is ways to work around it. So this will be a batch request. It would send 2 requests. Both will go to the same GraphQL endpoint, as again, we cannot use the REST endpoints because we try to compare it in an equal way. And the first request retrieves all the customers and all the fields available for customers. And the second request retrieves all the orders for a specific customer ID. I can run this in the same way as I can run my previous script. I just need to point it towards a different file. So this file is called multi.js. So it needs another 30 seconds in order to do it. So let me tell you the funny story I had about the first time I used case 6. I don't really remember how long it was, but it's not more than 10 years ago. I was building an application for, how to call it, like a TV guide application for iPad. And we had this agency, and they built the application for us, and they were really good at building nice-looking applications. They also built a backend for us that sort of retrieved all the TV programs that were being showed on the television every day and would render these in the application. As we were sort of testing, because we were like a week away from launching the app, we really wanted to know how it performed, because the only test we'd done was by opening the app, clicking through it, and everything looked fine. And we've done this maybe with 5 people max. We started sending requests using case 6 because I was sort of the technical product manager for this project, next to being a developer on different things. I wanted to figure out how it would perform if we would market this, if we would send, I don't know, maybe thousands of requests to this application every minute, because hopefully our marketing went well and we were able to drive traffic. So we ran this test and we actually saw a cutoff point where the API would perform well up until like 100 users, and then it would just sort of go still because the whole server environment maxed out, because it timed out, the cache was full, and basically the server didn't like what was going on as well. So of course we sort of postponed the launch because we didn't feel happy with just getting 100 users using our application. But it does show that you need to do some testing, and you need to do more testing than bringing 5 people in a room and have them click around in the application. You actually want to know how it performs in a real-life setup. So let's get back to our results. So what we've done this time, we sent 2 requests. We sent them in batch, and we selected all the fields that are available for sort of these REST API endpoints. So this would mimic our REST API setup where we would have multiple requests and we get all the fields even though we don't need them. The first thing we see is we load a lot of data again. So we have 7 megabytes of data, and we were able to do 4,000 requests. So 4,000 requests actually means we've done 2,000 iterations of our batch setup. So it's 2,000 times both the requests. So let me write this down so we can compare it. So for this setup, we had, let's see, 7 megabytes of data, and we were able to do 4,000 requests, or let me say 2,000 iterations is 4,000 requests. So if we were be working with GraphQL, we would do this slightly different, because if we want to retrieve a list of customers, and we also want to retrieve the orders, we can use nested data for it. So instead of having nested data for address, because it's in my REST request, let's say I want to get the name, email, and maybe some information from the order. And the information I want maybe is the carrier and the tracking ID, because that way I can maybe share the information. So let me see, is this called orders or order? And for this, I'm actually going to my GraphQL API to see what's the way to do it. It's called orders. So this is a GraphQL playground, as you probably saw if you've been working with GraphQL. And in here, I can sort of test my queries. So it's always good before you do these performance tests to also test if your things are working. Of course, I've done this before. So we have orders. We want to get the tracking ID, and we need the carrier. So in GraphQL, I can now get information from my customers, and at the same point, also get the information from the orders they placed, like this. So the information from this part of my GraphQL query, it would come from a different REST endpoint that would give me all the order information. Just get rid of this and save this. I have the query customer list, and I want to go back to my original setup where I'm not using batch, but instead I'm using a single post, and my query is called customer list. So this was the query that sort of combined the 2 requests. So I'm going to save this, and then I'm going to rerun this script for the final time, and then we're done with the demo part. So this runs my script again. This time we don't send any batch requests, we only send single requests, and we combine data from both of the requests in a single GraphQL query. So I'm expecting to receive less data because we got rid of all the fields that we don't use. And I also would expect to do slightly more requests because we're sending just a single request instead of 2. So let me see. The data part is very true. So we went from 7 megabytes, if we go up here. So we went from 7 megabytes to 700 kilobytes. So let's say we are at 10% of our data consumption. And then if we look at the amount of iterations, it's pretty much the same. So the same as for our previous test, we done about like 100 more. So let's say, well, only a few percent. So this could be better. This is obviously something I could do to improve this. But already we're showing the biggest part is around the data. We were able to, in the same amount of requests, collect way less data. So using these simple performance tests, you can figure out if GraphQL would be beneficial for you if you're trying to compare it to your REST API setup. So if we go back to my slide, there's another topic I like to discuss. Should you use GraphQL? And I briefly touched this in the beginning. There's huge upsides for GraphQL if you're using REST. There's upsides for it if you are looking at sort of a data governance in your company. It really depends. So this was me at the annual GraphQL Conf. I like to say I'm biased. I like to use GraphQL, so I always try to convince people to use it. But I'm also realistic and understand it's not useful for everyone, or it might not be the best choice for every sort of stack you have or every composition of your team. So if you look at GraphQL, I'd say GraphQL is really good when you have a one-to-many or a many-to-many relationship with your backend and your applications. So imagine you have one backend serving multiple applications. GraphQL is really good here because you don't need to redefine all these different endpoints. You don't need to create specific endpoints for specific applications. It's also good when you have many-to-many, and I'd say many-to-many is when you have microservices and you have a whole range of applications. So you're trying to find ways to use these microservices, collect the data from the microservices, and create an API that you can reuse across different applications. If you're doing a one-to-one mapping, so you have one backend and one application, you can still use GraphQL, but you won't be able to get the full potential, because it might just be quicker for you or for your team to build a REST API endpoint and change it every time your application needs different fields. So GraphQL is really good if you're growing, if you're building multiple apps or multiple backends. And for this is something we call GraphQL federation. So this is where you would, and this is more of the microservice example, it's where you would build microservices, have GraphQL for every service, and then sort of bring this all together in one large GraphQL API. So GraphQL federation is really good when you're building these sort of subgraphs. And this is especially if you have a large organization, and all these GraphQL APIs could independently be used by different applications, and then you could also have this unified GraphQL API that's used by even a different application or by one of the downstream apps as well. So it's really good for these sort of situation where you like to compose your data and you don't want to compose it directly from your front end or from a backend for front end. And also for AI. And this is something I've been getting more and more interested in, and hopefully you all as well. So how many people are doing actually things with AI beyond using ChatGPT or GitHub Copilot? Is someone using tools like LangChain or maybe some of the open API functions or API endpoints? No? That's okay. So this is specifically where I find GraphQL to be getting better and better usable. The one thing I don't really like about REST API endpoints is that they either have zero documentation because someone didn't create it, or they have outdated documentation where the documentation was created once, sometimes using open APIs, sometimes not even, and people don't really update it. For GraphQL, all the documentation or sort of the entire specification is present in your GraphQL schema, meaning that for AI tools, they can just look at your GraphQL schema and they can already understand how they can retrieve data from this GraphQL API and how they can make connections between different data types. So for example, imagine you would be building a service that likes to get, well, go back to the e-commerce example. You're building a service and someone places an order and they'd like to know when they received their package. Of course, you can hard code it. So you can just hard code if someone clicks a button and asks, when will I receive my package? I will go to the FedEx or UPS or whatever you have here and collect the info I need. If you're working with GraphQL, you can define data types for all these different steps in your data. So if you would ask when will my package receive to a GraphQL API, the sort of LLM would be able to know the underlying data sources through the GraphQL API and then know if this package is is from this order and it has this courier and it has this tracking ID. I need to know, I need to go to this system and collect whoever is the carrier and then return something that's useful to you. It, of course, can also look at external APIs, it can look at your internal databases, and then it will be able to return to you whenever this is delivered. So as I mentioned, StepStone was acquired by IBM. It doesn't mean we stop developing the product, it means we have more time to look at cool things like this. So myself personally, I'm really excited for working with these LLMs, and especially if you have an API specification that's understandable by LLMs, such as GraphQL, then there's a huge upside for this on the longer term. Of course, if you're working with REST and you have Open API and you keep it updated, you might be able to get similar benefits. So thank you. If you want to try out the code, you can use this QR code. And of course, I'll be available all day if you have any questions. So thank you.